Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean is the simplest cloud platform for developers and teams with products like Droplets, Spaces, Kubernetes, load balancers, block storage, and pre-built one-click apps. You can deploy, manage, and scale cloud applications faster and more efficiently on DigitalOcean. Whether you're running one virtual machine or 10,000, DigitalOcean makes managing your infrastructure way too easy. Get started for free with a $100 credit. Head to do.co/changelog. Again, do.co/changelog. Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel in Gopher Slack. Follow us on Twitter, we're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hello everybody, welcome to Go Time. I'm Matt Ryer. Today we're talking about testing, and I'm joined by some great thinkers and tinkerers from around the Go community. I'm joined by Johnny Borsico, Jana Bidogan, and the one and only John Calhoun. Hello everybody.
Hello.
Hello.
Hello. Hey, Matt.
How are we feeling today?
Feeling good.
No complaints.
Good. Well, if you do have complaints, don't bring them to me because I can't help. Especially if it's anything medical. Okay, so yeah, testing is such an important subject, I think. So it's great that we get to do a show on it. And I notice whenever I talk about testing, it always creates a lot of debate. And I always wonder why that is. You know, you'll hear some people say, TDD is dead, and other people advocating for it, and some very diverse opinions. And I think that says something about testing, which hopefully we can uncover today. But perhaps it's worth kicking off with talking a bit about the things we like about testing and the positivity around testing, because there's definitely lots of negativity around it too. Mm-hmm. So yeah, first of all, let's start off. Let's assume that we are joined by some people that are just getting into Go, haven't done much testing before. So what's the point in testing? What do we feel like? Why do we do it? And what do we want to get from it?
It's a way to understand myself, I think, right? Especially in the long term, and a way to express what my code is supposed to do. It's kind of like a summary. You just explain what it's supposed to do, and you have this repeatable way of checking if it's actually doing.
Yeah, so essentially, so you just want it to describe in some form other than the code itself. You want it to describe what promises you're making.
It's sort of actually it's a code that explains itself, right? When you said it's not a coding way, I just kind of assume that you were talking more about some specs or some hey, this is what it the project should behave like, more of a specification. But code itself is a spec. Testing is a spec itself, but it's code as well.
Yes, it's code. So yeah, so just very practically then, in Go, if you write a function, let's say, and it's going to be a greeter function. It's going to take in a name and it's going to say hello to that name and return that as a string. You could write a test which passes in some names and makes sure that what gets returned is what was expected. So that's essentially a unit test. And then what that gives you is you can look at the test code and you can just sort of see at a glance what promises are being made or what your function's meant to do. And of course, one of the goals, I think, of good testing and good practices is to have those tests continuously run such that you know that you can at least assume that they all pass. And that way we get a good feel. It's a great way if you're looking at a new package to to get a sense of how you should use that package, you can go and poke around in the test code.
Yeah, totally.
So one of the to sort of piggyback on what Yana has just mentioned, like for me, the tests sort of take on a different meaning as the project goes on, as the project goes, right? In the beginning, I'm trying to think through the problem I'm trying to solve, and I'm basically saying, okay, let me establish some specs around what I expect it to do. But over time, as the project sort of lives on and features get added or removed or whatnot, they become more of a sort of a guardrail, right? They become more of a sort of a letting me or confirming, right, that the changes I've been making, right, the things that I assume are still true have remained true, right, throughout the sort of evolution of the software. So they take on a slightly different meaning, I think, as the project evolves.
I think it's also, like, related to that, I think it's true that tests give you a good chance to clarify on things. Like, a good example is when I play board games, my friends always joke that I'm the person who thinks up the weird edge case and wonders if there's any, like, clarification in the rules for it. But, like, test cases are a great way of saying, like, if you give me this weird input, this is exactly what you're going to get back.
And this is, I think, why coverage is really important, because coverage kind of also, like, you basically declare what you expect by covering those cases. And sometimes I'm seeing people just going over like test cases and assuming that like maybe this package or this function is not supposed to, act like this way because it's not, represented in the tests. So it's important. Why I think one of the reasons why coverage is so important.
Yeah. And I think, it's easy to get a little bit obsessed with coverage too. I've met people who say, they're very proud of it. They have 100% code coverage. And essentially in Go projects, that means they've tested in some way all the points at which their code could error, for example.
Yeah.
They have test coverage for that. So
I would say that like for dynamically typed languages, 100% is definitely required. That is the base minimal. Right. But yeah, 100% doesn't necessarily mean, it's good coverage, or it's necessarily important.
I think it's important to recognize what coverage actually means, though. Like Matt said, if you're just saying that you cover all of the code, is that really 100% coverage? Because, you didn't try every integer input. You didn't try, every string input. So, you can have coverage in the sense that it touches all of your code, but that's nowhere near actually having covered, 100% coverage.
Yeah.
Does this mean also you need some fuzzing, or you need to just force it to with different inputs and so on with all the possibilities? You need to be a little bit smarter. Maybe you cannot really manually, generate all those test cases, right?
Yeah. Because for me at least, I would rather work on a code base with 75% code coverage, but that coverage is actually well thought out and it's good, versus somebody who's like, hey, I've got 100% code coverage, but it's just the simple, really basic inputs for everything, and it doesn't really actually test if things are going to work when, crap hits the fan.
Mm-hmm, mm-hmm.
Right, happy path and everything else, right?
Yeah.
Yeah, but if you do have that 100% code coverage, aren't your tests going to be overfit, really, for the test code? Essentially, your real code, your program code becomes very brittle. Every change, every tweak of the implementation could break these tests, because they've got coverage to that degree. So in that way, I think you can go too far with tests. I think a lot of people probably do. I definitely have in the past. And for me, it's about striking the balance between how much you need to do in order to have the benefits that testing brings you, but no more.
But isn't this a question about compatibility also? If you gave behavior promises, for example, you may actually want to be able to cover those tiny details so you don't change the behavior without you should be informed if your behavior is changing.
Yeah, and I suppose that's a good way of putting it. It's about what promises you've made. And this is where I think it's quite difficult to have these conversations in the general, because I think this will change depending on the kind of thing you're building. If you're building a binary encoder, decoder, then the test coverage and everything's going to look very different to if you're building an email sending service or something. Do you think?
Yeah, true.
Yeah. Even if you're if you talk about a website or something like that, technically to have 100% coverage, it feels like, okay, what happens if my hard drive fails? There's all these weird things that you might need to simulate, but is that actually worth doing versus, like you said, an encoder or something that's much smaller, you don't really have to think about all of that stuff as much.
Yeah, I think like unit tests versus, integration tests is a huge topic. And, like it's so complicated to run some of these integration tests that people would rather go to Canary and try to, take a look in production because the environment and all the glue is really complicated.
Yeah, so we should just spend a little bit of time just talking a bit about those differences between, say, unit tests and integration tests and the other types of testing that there are. For sure, unit testing, I think, is the simplest one to understand because it's the simplest kind of test. You have some kind of function usually. Dave Cheney did a talk at the recent Go meetup in London where he made the case that the unit actually should be the package. And actually, that's the boundary at which you should test. And he made some quite interesting points about that. But essentially, whatever it is you're testing the unit, that's the unit test. It's the smallest piece. You write the test code. It runs that real code and checks the outputs. And they're unit tests. So could someone tell us about what's an integration test then, if that's a unit test?
I've heard different definitions of integration tests, right? So it's almost like whenever I personally start talking about it, I have to sort of give like a preamble, right? Okay, when I talk about integration tests within this project, this is what I'm talking about. But basically, the basic idea is that given a solution, given a piece of software that solves a particular problem, are the different components within that solution well integrated as such that they can perform the given, basically they can solve the problem, right? Can the components work well together, right, to actually deliver the solution? So you can have just 2 components, a dozen components, hundreds of components, it doesn't matter. Do all these pieces within the bounds of your software, real solution, right, without talking to external sort of entities, can these things talk to each other? Now, there are others who think, well, integration testing means you go outside the boundaries of the immediate piece of software, of the immediate sort of repo or whatever the project is. Now, can it talk to, say, an external service like a database? Can it talk to other, APIs? And it's almost like you kind of have to sort of qualify what you mean by integration testing. But at least I consider it as within the project you're working on right now, do all the pieces in it fit together well?
I think like one way, like piggybacking on that a little bit, that I've heard it described that I think it helps sometimes is if you think about it as like I'm testing this one package or component or whatever it is, and like it's interacting with other things, and you have to pretend that like I'm not going to be changing that code. So I have to make sure that like what I have works correctly with those things.
Yeah, and I think you run integration tests like after your unit tests because you want to make sure first the module itself is like running, and the integration test is only handling if it can like work together with other modules, right?
Yeah, like one of the examples I've always liked to give is you could write a unit test for like, let's say you're connecting to a Stripe API. You could write a unit test for it and say like, as long as they give me back this this response, my code works correctly. But you're never actually verifying that Stripe gives that response back. So if we assume that like the Stripe API, let's say assume you're allowed to talk to third-party services for your integration testing definition, the integration test might be the one that actually talks with Stripe and says, do I actually get the response back I expected? So like the two sort of have those 2 separate purposes that helps clarify what they're trying to do.
Integration tests are actually really interesting because while they are classified as functional tests, like functional as in you're actually seeing if the system is behaving as you're expecting, but also it really relies on the reliability of those external services and like, all these internal different modules. So it's kind of like somewhere, I think, in between like functional and non-functional testing, right?
I think that's what makes it so hard is that every company, depending on what all they rely on, has such a very different understanding of what an integration test is.
Yeah.
If you think about like a Google, when they release something, that it's a very different scale than like if I were to take something and throw it up onto a small Linode server or something. That's a very different experience than like somebody Google is going to release something. So like the integration testing is going to be vastly different.
Yeah, I mean, even within like large companies, there are also different like approaches to these problems, and it really relies on depends on the project and the problem and so on. So it's really hard to give some common advice on this topic.
Yeah, absolutely right.
So this kind of touches on an interesting bit as well, which basically like when when I know I'm sort of integrating with a third party solution, right? Basically, because you want to make sure that during your unit tests, right, you're not necessarily hitting right those external entities, and whether they be APIs or databases, and some people can argue for actually hitting those things, but outside of that, right? So I may then say, okay, well, I want to be able to do mocking and subbing and these kinds of things, right? So then there's a balance you kind of have to strike there, because I've been bitten a few times by basically over mocking or over stubbing. And then I go find out, right, during, thankfully sometimes during integration testing where I'm talking to those services. But worst case scenario, I find out at runtime when the application is in staging or production that a particular endpoint that I was assuming some responses were coming back, in my stubbing and mocking, that's actually not the case. So if something has changed under the hood or whatever the case may be, I go find out too late in the process. So there's a balance that you're trying to strike there. But a lot of people sort of advocate for mocking and stubbing. I've started to do less and less of them in favor of actually, like Yana was saying, basically basically doing a canary deploy and saying, okay, does this thing behave right with actual live traffic? Does it behave the way it's supposed to behave, right? So basically trying to create less sort of fakery around the thing I'm building and actually feeding it live traffic and seeing how it behaves. That's a way more sort of an accurate representation of how your software is going to behave than all the mocking you're going to do around it.
I know that Monzo do that. There's a bank in London called Monzo, and they're written in Go. And I know that they do that. They have, I assume, test cards, and automated tests can execute on the live system, and essentially simulating people really using their cards and transferring money and, I suppose, doing all the features that they support. And that can just be continuously running in production, and you'll see kind of early signals. If any of that's broken, it will tell you that something's broken.
Yeah, I've seen like some cases where people just replicate some of the incoming traffic and like forward it to this like tested environment and try to see like in terms of reliability or performance is pretty much the same. Like that's how they actually do some of the performance tests. They need to simulate like something that looks like real usage, right? Like they either go with incoming traffic, or what they would do is like take a look at the events or logs and try to like replicate some time frame, like a 5 minute, and then they would run their tests.
Yeah, I built a thing once where we recorded real kind of HTTP traffic and saved them, and that became the test. That became the test files. I've seen it as well in Go packages where there's like, I think they call them golden files.
Right.
Yes. So you run the tests with a flag, and then it actually hits the real service and saves the result in a test file. So then in subsequent runs, or if you run it with the short flag, you can you can just say, assume that everything's as it was when we last ran these and got the real data. So that's quite a nice thing to sort of admits that we're doing our best here. It's not perfect, but it still gives us a level of confidence that's therefore worth having.
True.
So for those who are obviously new to Go and trying to figure out how do I do these types of testing in Go, what sort of advice in terms of technique could we recommend for these folks? In other words, let me actually give an example. So for integration testing, right? So if you don't necessarily want these things to be happening every time you're trying to perform your unit tests, right? Maybe the integration tests are more expensive and more in terms of time. Maybe you might name, for example, some of your tests with the word integration in them, and then when you're running Go tests, on a command line, the toolchain allows you to basically pass in flags, right? Maybe you pass in a name flag, for example, and basically say I want the name to be, or rather run. That's the flag I'm thinking of, to have actually the name, right, integration in it, and that way you can actually run specific kinds of tests, right, depending on what you need at any given time. That way you don't have to run everything every time you're trying to do unit testing. That's one example.
Yeah, I have a question. Are you writing your integration tests as like unit tests by using Go tests, or would you rather have like separate main like binaries or whatever, and just setting up the entire environment and then like running the tests?
I'd say it totally depends on the size of the project. Given a large enough project, we might have something separate, completely separate for actually exercising it, as opposed to saying, well, you know what, this is just a small, little microservice, and it does only, just a couple things, and we just want to be able to make sure that it can actually talk to some other service or do some other function. But yeah, you could actually do it a couple different ways.
Yeah.
I think part of it's also thinking about the project you're working on, like you just said. Because like Matt had talked about, if you're writing an API client and you're trying to test that it actually does things correctly with the endpoints, like one easy way to say we probably want to do integration tests is if they provide an API key, well, there's a good chance they're trying to hit the actual API. But if they don't, you can probably make the assumption in your tests that that's not what they're trying to do. So like you had said, you could pass the run flag. It might also be a flag that says like provide an API key, or there's also build tags, which I like, but it's a little bit different.
Mm-hmm.
What I like to use to environmental, environment. I take a look at the environment and skip things, and I usually like have some utility function. I have a testing package with a utility function that automatically skips if the the variable is not set or something. So it's really like a common approach I am trying to like follow in every testing in every test. I would basically take a look at the environment. If there's like enough credentials or whatever, I would just run the integration tests. Or if there's a specific environmental variable that says that like run integration tests, I would do that. Otherwise, that function would just skip, and I would make that function call in the beginning of all of my test functions, so I don't have to think about this problem again and again.
Yeah, and the goal of course is that we want to run the unit tests very often. You want to keep continuously running them. And I even have it where I hit save and it will run the tests for that package. But of course, you want that to then be quick. You need that immediate feedback. And with Go, you do get that, especially for unit tests. Of course, integration tests, they're usually slower. And I think that's the value in having them run them less often. It's just because you don't want to get in everyone's way, and you want to encourage running of the tests, because if you leave the code, it sort of goes stale. This is one thing that surprised me when I first became a software engineer. I thought if you left code alone, nothing would change. But it's not. If you leave it alone and don't look at it, and you try and run it again, it's just everything's broken. So yeah, we want to definitely encourage.
There's not like self-contained code, right? Like there is all these dependencies, and dependencies change even if you don't change the code. There's no such thing that, code that doesn't change. Unless you are writing your operating system and everything from scratch, you have like the absolute control on the hardware and never changes, then we can say that like it doesn't have to change.
Yeah, but then, of course, we also have flaky tests. And I always thought of testing as a scientific thing. It's almost the scientific model. We set up an environment, we make some estimations, or we make some assertions later. We perform the same thing, we take the same steps, and then we test it. And it feels very scientific. But actually, in practice, tests can just sometimes, they'll just be flaky, and they just will fail sometimes and things. And if you get the level wrong, I think, as well for a project, and that's what that means is quite a deep thing, I think. But if you get the level wrong...
When you say scientific, you mean it's consistently reproducible? Because like I see that it's a science to have like, it's like a different science to handle the flaky tests, right? Like people are running all this like statistical stuff just to make sure like what is actually a flaky unit case and what is really important to care about and so on. So it's like a huge topic on its own.
Yeah, no, it is. It's tough. I really just mean that I can't believe sometimes tests will work and then sometimes they just don't work. So for junior developers or for people new to programming in Go, and you start to experience that, yeah, it's weird, but it's real. It happens.
Yeah.
This episode is brought to you by StrongDM. StrongDM makes it easy for DevOps to enforce the controls InfoSec teams require, manage access to any database, server, in any environment. And in this segment, we're talking to Jim Mordko, VP of Engineering at Hearst. He's sharing how they're using StrongDM within their team of 90 plus engineers. It now takes them just 60 seconds to offboard a team member from a data source.
We have an engineering team of somewhere in the area of 80 or 90 engineers. Because we've got so many services and many databases and so many developers, we need a reasonable way to manage access to them. It was a somewhat painful and labor-intensive process. Our DevOps team would literally have to manage every one of the permissions for everybody who wanted access. So StrongDM has been a real godsend in that area for us. Requests for access to specific databases were pretty much manual. Now we've adopted StrongDM. It's something that you don't even know is there. Once it's installed, it just works. It's very simple. We've set up a multitude of data sources so that when somebody's onboarded, we just give them access to StrongDM. It's pretty simple. Our DevOps team, they have a very minimal effort required to enable each data source to be connected to StrongDM, and then installing the client software is it's very, very simple and straightforward. You can use whatever client you want to talk to the database, so there's really no training necessary.
All right, if your team can benefit from nearly instant onboarding and offboarding that's fully SOC 2 compliant, head to strongdm.com to learn more and request a free demo. Again, strongdm.com.
I worked at a company at one point that like literally the end of every month, there was like a 24 to 48 hour period where like some of the tests just failed. And it was because somebody did something weird with time wrong, and I don't remember what it was, but it was like the most frustrating thing because everybody basically just ignored tests during those 2 days and just checked code in. And it was just like, what are we doing? And then like after those 2 days, it was just like, let's try to fix everything and not release anything.
Oh, yeah, that's like the most dangerous part of it. Like once everything is becoming, if there's at least one flaky test, people learn how not to look at the test results and like they just entirely ignore testing, right? Like that's why it's really important to, do something about flaky tests.
Yeah, that's a great point, actually. That's exactly what happens. If something's just annoying, you as a developer, you've actually got work to do. You haven't got time to fix someone else's test where you don't have any context about it. So yeah, it's very common that what will happen is you just stop testing, you just stop writing tests. It's too messy, it doesn't work, just comment them out or something. That's what happens in real life.
That's definitely the number one reason I've seen for companies to stop testing as much as they should. It's because tests aren't working, so people aren't listening to them. So that leads to people just no longer writing more tests because what's the point?
What do you do when there's a really flaky test and it's not really easy to actually fix it? But I know that like it's going to actually damage the testing culture if we keep it in the test suite. Would you remove that momentarily until you figure out, or would you keep it and try to tell everybody to be careful because just because one test is flaky and is failing very often doesn't mean that we shouldn't care about testing.
So one thing I've been experimenting with, which I still don't know how I feel about it, and a lot of my development is done in smaller teams, but if I see tests like that, I tend to use build tags for my tests. So like I'll have a build tag for integration testing and stuff. I'll actually throw things in like a flaky build tag and just basically say, these are all the tests that are known to be flaky. So then people know, like, if you aren't running that tag, you shouldn't be ignoring tests. But if you're running that tag, then there's a chance it could be because it's flaky. So like at least then it's isolated so people know, when to ignore stuff.
Yeah, it's a great approach.
But hold on, what are some reasons why tests can be flaky?
Just imagine that there's a concurrency thing and like you don't have the API to like manage the concurrency, and then there's no determinism, and you can't really like simulate one particular case or whatever. It could be for multiple reasons and you don't maybe necessarily know what you can do about it right now. But, you may want to work on it and maybe it will take a week or something to actually come up with a decent test that is going to replace that flaky test. So you may want to momentarily at least just label it as a flaky one and still keep it around.
Jana, would you ever change the design in order to make testing easier?
In terms of what?
Well, for example, if something's non-deterministic, but you could change the design in some way or redesign the component.
Yeah, definitely. I mean, you would totally redesign, but imagine that like you don't have like access to change for example, let's talk about concurrency. There is this like concurrent playback scheduler that you want to test. And it doesn't provide you the right API, so you cannot like create that like momentarily, you cannot like intercept, you cannot like change the behavior of the scheduler. You cannot like really stop the scheduler to check if everything is fine along the way. So like, you have very limited options there. You would either not test that case, or you would just ask them to give you some hooks so you can actually make the schedulers testable. But what would you do if you are actually limited to test a case and there's no deterministic way to test a component.
It has happened to me before, and it's a pain. One of the things we did, and I really don't advocate for this, but it worked. This is a part of the disclaimer here is that developers will just hack anything to make it work. I ran it in for loop because it mostly was fine. So I let it run like 4 or 5 times. And if it failed every time, then it was a fail. If it passed any one of those times, I knew that it was okay. But that doesn't feel great. I didn't go home thinking, yeah, I'm really good at computers today.
Put that on your resume.
Yeah.
By any means necessary, this test will pass.
Yeah. But that's the attitude, though. That we have to remember that is what people are doing. They've got some other thing that they're trying to achieve. So they'll do anything. It's very natural. And we should, as individuals, fight it. But anyone that's building tools or designing frameworks to help in this, they should for sure bear that in mind.
I think we just do a terrible job in terms of like thinking about the testability of anything we design. Like our API design, we had this show about the API design, but we never talked about testability. But necessarily we optimize a lot of things around usability. But when it comes to testability, we're just always it's always the second priority, and we end up like having either flaky tests or like non-testable code or like over mocked situations, which is not really nice.
Yeah.
Jana, are you talking about sort of for example, like a practical example might be that you say you write a Go package, and you expose sort of some sort of testing facility, right, for the consumers of your package. So we're not talking about the test you write for your own functionality, but really exposing something that others who are integrating your package can use to test.
Exactly. Or like design an APIs in a way that it can be mockable or testable, some certain way. Like just keeping in mind that I think something needs to be testable by the user is just a good exercise, but we don't necessarily care too much about it when we are designing APIs.
Yeah, so that's funny because when we did Machinebox, that was a conversation we had a lot, which is we made sure that people would be able to test this stuff and stub it out easily or whatever they wanted to do. And I think it should be a first-class concern. But of course, if you're generating code or, if there are other mechanisms, and every project is different, that is a difficult thing to keep thinking about. But TDD helps me do that because I usually put my code, at least by default, in a different test package, so that I am testing it. I'm testing the package externally. So in order to test it, it has to be testable. So by its nature, TDD helps me achieve that. And sometimes I'll notice patterns that we're doing a few times, and I'll put them in the docs for people, or even create a little sub-package or a little package inside this one that provides some kind of common or simple testing thing and just gives it to people. I quite like that.
Mm-hmm.
So in doing that, did you notice anything that you could design that like make your packages less testable? Like did anything stick out?
Yes. I mean, any kind of global state, suddenly you have to care about, you can't just run your tests in any order. I like to be able to run unit tests in any order that I like. And I like to be able to just run one at a time if I'm just working on one little thing. And sometimes every time that you have state somewhere, you have to care about that. And, sometimes it's nice. You get these little DSLs coming through where you can just say, okay, log in as this user and create these things and then do this. And then you make the real kind of function call or the API call or whatever it is. And then you can kind of go and check and make sure things happened as expected. But that's a lot of work to do for a unit. So as long as it runs fast, though, I will do that. What else is difficult? Concurrency is hard to test in Go. But you can, it depends. Like sometimes I think sometimes you have to kind of trust yourself as well. We want these projects to have this great coverage and for us to have the confidence that we can put it out there in the wild or ship the code knowing it's going to work. But if you've got like a little select block that's really difficult to test, what's the harm in leaving that bit untested and just sort of rely on the fact that almost nothing's going to work if that thing's not working? So we sort of know it is working. Does that give you warm fuzzies at night, or does that worry you?
I'm more willing to let things like that go, but I also am in a very different environment than most people. As in, like, I'm not working at like a Google on something that deals with billions of dollars. If I was doing that, it might make me a little bit scared at night.
And what, context that you have, where you're working, what the project is, all that stuff probably does play into this, doesn't it?
I'd say definitely. Because, I mean, if you think about it, if you're writing something that, maybe it's a little store that you're going to make $100 a month on, well, if you have a little bug, at most, you lose $100 that month or something. Whereas, like, if you're a Google and, you could actually lose millions of dollars because you didn't test something.
So there's a risk assessment element then.
Yeah.
You have to assess the risk when you're testing because it is effort.
Mm-hmm.
One of the reasons I hear people don't like TDD is because it just takes too long to build anything. That for me isn't true now. I'm actually faster with TDD because of the focus it gives me and the speed at which I can write code because, if it's wrong, I'll quickly see that it's wrong. It actually allows me to go a lot faster.
But isn't TDD? So I have a question about TDD. I do think TDD is a good choice if you have a really, clear spec, right?
Mhm.
Like it's more of like you have this encoding, decoding spec you want to implement, and it's just like there are clear cases, and it's I think awesome. But maybe it's not that awesome if you're writing a web server that talks to like 5 other servers, and it's just like not where I would start with. So what is your opinion on this? Like, do you think that like TDD is applicable to lots of different problems, or is this just like really where the spec is really clear and self-contained?
I think the other thing is it depends on what your definition of TDD even is.
Mm-hmm.
Because I've heard some people that say TDD is literally writing the minimum amount of code possible. Like you write a test and you write the minimum code to make that test pass. And I don't function that way. It's just not how I work.
Mm-hmm.
Yeah, it can. I think that's like extreme TDD. That's like fundamentalist TDD, I think. But
Is that a terminology you just coined? Extreme TDD, XTDD.
Yeah, but
well, I mean, yeah. So here's the thing. I mean, this TDD debate has been going on forever. Like with my teams, I usually tell them, look, I don't particularly care if you followed TDD or not when coming up with a solution. As long as the stuff you're committing and are issuing a PR for, as long as it has tests, I'm good with it, right? So to Jana's point, when I'm experimenting, right, when I don't quite know exactly what it is that what shape this thing is gonna take, right? Like I don't start with tests first. And again, that doesn't mean it's the right way, it's the wrong way. It's just, how a person, right, how a developer, that particular developer, how they think about things. We don't all think the same way. So we shouldn't take the TDD thing as gospel, right? We don't have to be dogmatic about it. It's all about, at the end of the day, right, is this code that is about that a developer is proposing to be the solution to the problem, can we verify that, right? And to me, that underlines the value of tests, right? You are telling me that as a developer, the solution you are proposing is correct, and this is the test that says so. That is, to me, the ultimate value of the test, right? So that when somebody else picks it up and they start to make changes, they know exactly what is expected. And if it breaks, they know what it is they need to look at to fix it. So that's the ultimate value of the test. I don't care how you come up with it, as long as you have them.
I think that's fair enough. The one thing I'll say about that, though, is writing unit tests for code that's already been written is one of the most soul-destroying things I find myself having to do sometimes. Writing tests as it's being developed, that is a very different experience. The end result can be the same. It's usually better with TDD because it depends on if you're doing it well or not, I suppose. But yeah, you're right. You can't go too far and be an extremist about it. But there are cases where it really is the right way, I think, to build a particular thing. Of course, if people... when you're sketching ideas, you just want to open a notepad and you're just sketching things and stuff. Mm-hmm. Yeah, that doesn't really count to me. It's part of the process, but it's not part of that. You're not implementing that production thing. It really is a different mode. So yeah, but even then, even in those cases when I'm just hacking on something, if it's a Go package, I will definitely start with tests personally because that's how I think about. I mean, that's really, I become the first user of that package. And I think that's the right way to write code and to build packages.
Are you doing this before or after the API design? So I'm just wondering, like, what is the overhead of writing the tests first? Because I feel myself like even if I will follow a TDD approach, I will try to finalize my API design first, and then just basically, put my API in my main package, and then create a test file, and maybe put some tests and start to implement the functions.
I probably don't do it exactly like that, but to be honest, I wouldn't split any hairs over it because I think Johnny's right. As long as the end result is kind of the same, I think it's okay. But yeah, I will. If I've got an idea for a Go package, I'll start with tests where I'm just trying to use the thing, imagining it exists, and I just start to use it. And that's how I kind of do API design, most of the time. And I'll say, oh, okay, so now I'm calling this package. I need to be able to set this. I need to be able to set an HTTP client. So how am I going to do that in the design? And I sort of try and just be the user. And I think even if people are sketching, even if you're sketching code elsewhere, it helps if you're trying to be the user. I think that's the important thing because that's who we're building it for.
I think I have a similar approach, but it's really limited. Like it's not really all the test coverage. I call this like example-driven development. I would just, start with the Go examples. So I can actually have a feeling of like what it's going to feel like for the user. And I would only, write examples for like 3 main cases. And then, it helps me to shape the APIs.
Yeah, that's great.
I follow something very, actually, it's interesting because obviously we all have slightly different approaches. I do the same thing, but with READMEs, right? Like I basically say, okay, if I were to go into this project and I started looking at the README, tell me about usage, right? Tell me like what to expect. What am I doing? What am I doing? What am I starting with? What is the entry point into this package? What is the typical way that you'd use this thing? So it's like I'll start with the README literally because I've done this many times, both for myself and for members of my team, whereby I may not necessarily be the one implementing the package, right? But I will come up with the README, right? And I can hand that over, to a different developer or a different teammate, and then they know exactly what my expectations are, and then basically that becomes a basis, right, to actually talk about designs and trade-offs, and even before a single line of code has been written. I find it to be like a tremendous way of actually wrapping your head around what it is that you're trying to build.
Yeah,
and I suspect a lot of us do design differently as well, because for me design emerges for sure through that process. I have done before, as you described, Johnny, where you sit down with it's kind of document driven development almost or something. In fact, we made a little tool called Silk, which was a markdown file, and you just described your API with it, and then you could run that markdown file against a real API. So it was like halfway between documentation and real test code. That idea of that came out of the fact that, as you mentioned, Jana, those Go examples are actually runnable. So it is an example, but you can run it and it'll fail if the output doesn't match and things like that, which is really cool. I love that in Go project, testing was a first-class concern, a first-class citizen. That has really helped the language and the community, I think.
Mm-hmm.
So we've talked about TDD, but there's a whole other discipline, right? BDD, which kind of sounds like what you were talking about just now, Matt. The whole behavior-driven development, which we actually have popular packages within the Go community that sort of adopt that approach. Like, have any of you tried that and liked it or didn't like it? What did you think of these kinds of this approach of actually writing tests?
I can say I have no problem with people using it or whatever. One of the things that I tend to dislike about BDD is that most of the packages for it expect you to like almost learn a new language.
Mm-hmm.
It kind of feels like I already learned Go. I want to write Go code in my tests. That way people don't have to learn new stuff. And it's not as bad in Go, but like I remember in Rails or you're writing in Ruby, it really felt like you weren't writing Ruby anymore. It was like, I got to learn this whole new thing to learn how to test. And it's like, I don't want to learn something new.
Mm-hmm.
And you're doing the same thing, aren't you? I haven't done much of it, but isn't it just that it's a different way of kind of doing the same job, which is it's going to run some code and you're going to make assertions about it. Doesn't it have just these fluent kind of APIs so that you can say, it should do this and this should equal this, and you can kind of speak it out almost.
Yeah, isn't it the difference is more of like the organization of the things and like how you actually like, express, like, I mean, how you maybe it kind of helps you to also self-document what is related to what, but isn't that the only difference?
I was sold on the notion that if you wrote behavior-driven development style, sort of self-documenting, right, almost English, sounding ways of describing functionality, that folks outside of the development group would start to get into it. Things like that. Some of the like Cucumber, for example, from back when I was involved in Ruby and Rails and doing more of that stuff. There's the language underneath. I think it's called Gherkin or something like that. There was this promise, right, that you'd have people other than engineers, writing the specs that they can then hand over to the development team, and they could just write tests against those things. I have actually never seen that come true ever.
I think because nobody actually cares, but I think originally it was really important to explain who is actually why we are testing this case. Like, I mean, you need to answer some questions like, right, who is the person that is going to get benefit from this behavior, what it is actually trying to solve, and like why is it doing it, like and you need to express this in regular English so people can just go and like see and explore. It's kind of like having this like product design document as a test suite or something.
I think the other issue is that if you take somebody who doesn't really write code, more than likely a developer could misinterpret their tests and write something that passes all of those tests but comes nowhere near doing what they actually wanted it to do.
Yeah,
so it hasn't worked, has it?
So I don't think it's ever going to work, because it's almost like other people have to learn like how to keep the coder happy, and at that point it's like, well, you might as well just write it up in a doc anyway.
Yep.
This episode is brought to you by O'Reilly Velocity Conference in San Jose, California, June 10th through June 13th. To get ahead today, your organization needs to be cloud native, and O'Reilly Velocity Conference covers everything from Kubernetes and site reliability engineering to observability and performance to give you a comprehensive understanding of applications and services and stay on top of the rapidly changing cloud landscape. They have amazing training, amazing speakers, and of course, an amazing community. Hear from industry leaders like Lena Hall, Julie Horvath, Liz Fong-Jones, Emily Freeman, and more. Learn new skills, approaches, and technologies, and get expert insights and essential training on critical topics like chaos engineering, cloud native systems, emerging tech, serverless, production engineering, and of course, Kubernetes. Learn more and register at velocityconf.com/CA. Again, it's in San Jose, California, June 10th through June 13th. Plus, our listeners get 20% off bronze, silver, and gold passes when you use the code GOTIME20. Again, velocityconf.com/CA, or check the show notes for details.
Well, listeners, remember, you can join in the conversation on Slack. We're in the hashtag GoTimeFM channel, and you can also Twitter at GoTimeFM. And actually, speaking of that, Corey Lanau in the Slack channels just said, "I've written tens of thousands of lines of test code and have yet to ever feel like I need another package to help me test." So how, dear panel, do you feel about standard library only versus user framework, or use some other tools?
I'll say this. As far as, I think this is like everything we've talked about. Everybody's going to have different preferences, but the bigger thing to me is as long as a whole team or a whole project can all settle on one thing, I think that's important. Like having consistency across a code base or a project or whatever you're working on is far more important than the specific details that you choose.
Yeah, I think it's also like the tooling is really important in terms of having some consistency. I would rather like there are some tools, like there are some testing frameworks that kind of like comes with their own flavors of tools. And I'm trying to like stay away from that because I want everybody to check out my code, especially if it's open source, and run the tests without learning anything new, right? Like that's really important. I care about tests. I care about people running the test. That's why I want to make it as approachable as it is. And I'm just generally personally happy with the standard library testing package. But as soon as like any testing framework supports Go test, I think I'm open to try.
Do you write little helpers like for equality checking or for not nil or not error? Do you do anything to help yourself?
You mean like testing utilities?
Yeah.
Yeah, I have a testing package.
Oh, so you have your own testing package?
Yeah, I have like some utilities. I was mentioning that, like for example, it automatically skips the integration test if it's not in the environment or whatever. So I try to maintain a testing package for every project I actually maintain, but it's more of like per project and depends on I put the utilities depends on the requirements.
I personally have used the Testify Assert package because it provided sort of that core basic utility sort of aspect that I was basically finding myself sort of recreating from project to project. It comes with some extras, and I tend to not use those. I think it has mocking as well and some other stuff. I think just being able to assert, using that assert package has been sort of has made testing a little easier, a little more approachable. For some reason, though, and I might not be the only one who feels this way, but like when I first started Go, I almost like I wanted to bring like some habits with me from other languages, right? Like, if you're doing Ruby, like you don't know, nobody that I know writes with the standard, writes tests without any sort of framework, in Ruby or Rails, right? You always bring in like RSpec and you always bring other things. There's this tendency to sort of, I had that tendency to just basically look around. Okay, what things can I bring into this Go program to make it more, akin to what I used to do? And over the years, I've sort of regressed on that, right? Basically, I'm like, okay, well, by default, can I try to do this in this with a standard library, right? What is the trade-off if I bring in, I try not to bring dependencies that I can simply, if I can copy and paste like a few lines of code, I'll do that rather than bring in the actual dependency itself. Or if it's maybe slightly a little harder, more verbose with the standard library, I may still choose to do that because, like, personally, if I don't have to bring in a dependency, like I really, really, really try to avoid it. Maybe I've been bitten one too many times with third-party packages, but like I really try to do it all with the standard library, even if it's slightly a little uncomfortable and a little painful.
I think this goes back to what Matt said earlier, where if you let code sit long enough, you used to think that it would work, and later when you go to run it and it doesn't, a lot of the times it's because some third-party package changed and your package manager wasn't, there wasn't one at the time or something happened, and you're just like, I don't want to have this happen again.
Mm-hmm.
Yeah, but your point, Johnny, about the other, the inertia that people have from other languages, that is exactly why packages like Testify, I think, still is one of the most imported packages in Go. Full disclosure, I started Testify with a friend of mine, because I was working in other languages where that was how I thought about checking for equality. You just throw them into something, and it was its responsibility to check it for you and print it out nicely and all that stuff. Do you think Go would benefit from having some way of saying like assert, at least for the common ones, like assert or check that this error is nil, or those kinds of things?
You can write it yourself if you really want to have that. It's
a couple of lines. It's like so trivial. Yes.
Yeah, you don't need a whole package to do that. Yeah.
It's almost like at this point we're arguing whether or not this should be a third-party library or in the standard library, and because it definitely exists in third-party libraries. So the only real change would be like if you're willing to import something.
Yeah, that's what I mean. Though, is it worth having? Is it worth getting promoted? Because I feel like Testify made the case for that style of testing, and to be honest, I think if you look at the API for Testify, it's really grown. It was a very liberal project where anyone's kind of contributions were very welcome, and And so what's happened is it's a big package. It has its own dependencies, quite a lot of them.
Yes.
And really, like you say, people are just after the assert equal and a little handful of very common things. Could that not be on the T? So you could do like T.assert, or is it just not worth it?
I think it would be better for like Testify to split itself across a couple packages or something, or it might maybe have one package that imports all of it. At least to me, it's a great stepping stone. Like if you're learning Go and you want something that makes you feel more familiar, like I love having things like that. But there's enough people that I think would get upset about it that I just think it would cause way too much of a ruckus to bother with.
I think there are also like going to be a number of different APIs in order to, support all the like fail cases, like assert, for example, assert if not nil, but put out this error message, or just log fatal, or like should I log fatal, or should I like just log printf, right? Like there's like all these like different things that you may end up adding to the standard library package. I think it's just like it would require such a large API surface, if you ask my opinion, to add that type of utilities. I think within your own project, you can be more opinionated and say, hey, if there's an error, just like log fatal in this like, error format, and like this is the, error message. But I think like in order to add any type of these utilities to the standard packages, you need to cover a bunch of different cases, and I think I think it's not worth it to put it in the standard library.
I also don't like the idea of having like too many ways to do the same thing with the standard library.
Yeah.
Because like that's one of the things that drove me insane about working on Rails projects is like everybody had their own definition of like how you were supposed to iterate over an array and do something with it. And I'm just like, I don't need to learn 17 ways to do this.
I think if something is not in Go as a language feature, or is not in the standard library, it's because like there are so many different ways to do it. So like they just cannot like put an opinionated API or a feature, or they don't want to like, they want to keep being an orthogonal language, and they would just like stay away from adding more noise.
I think it's also pretty easy to make the decision of if you want to import something. Like if you're writing a really small package that, like you said, if you're just writing an encoder, decoder or something, then yeah, it doesn't make sense to import other stuff. But if your package already imports 50 other things, adding one for Testify is really not that big of a deal.
Sure.
What other things do we like when we are testing in Go specifically? One of them that always stands out to me is I love the way that we can just do table tests in Go, where you just have a slice of anonymous struct that contain any fields that you like. It depends on the case, which is perfect because it's another opportunity to tell a bit more of a story. And then you just immediately instantiate with some test data, and then you just loop over that and run some target method or some target function, or you do something with those inputs. And then the table tests also contain the outputs. So that as a little pattern, I think, is a great one. Are there any other?
I never leave home without it. Really, I mean, even for like single case, tables, basically. Because the thing, what I found over and over and over again, even when I start to think that, well, maybe there's really just one case here that I'm trying to test with this. Eventually, right, I'll either find an edge case or find some other input, whether from the business or from looking at, in the course of actually coming up with a solution. I'll find out, oh yeah, there is more than one case here. So I end up creating a table-driven test anyway. So right now, I just right off the bat, I just start out with it and just put the case I know of right now, and then over time, it's easy to simply add a new one. Just copy and paste it into the next line, or comment out one line at a time to test in isolation. I mean, I really don't have any tests without it.
I really like that it actually encourages people to add more cases. So that's what I realized, that if I actually start with a table-driven test, people will add more, cases over time, because it's like less boiler for them to like create a new test function and so on. So it really also encourages people to add more tests.
Yeah, it's also great for people that are new to programming in Go. If you're looking for an open source project and you want to contribute, you can go and have a look at look in the test code, because there might be, you might know something about that world that the original package writers didn't know. Yeah.
Yeah.
I agree. It makes it easy.
Yeah, one more thing I like about table-driven tests in Go, some of the editors actually can generate the test in a table-driven way. So you just automatically get the boilerplate, and you don't really have to you don't have to even pick you can just auto-generate the table-driven style test, and even if you have one case, you can keep it as that way, and then more people will come in and fill in.
Have you ever found certain situations where it feels easier to not necessarily to not get to a table-driven test, but to instead start with something more straightforward and then come back and see how can I make this a table-driven test?
No.
I think I have one problem with table-driven tests. It's so hard to say just only run it for this particular input, right? It needs to be run for everything, the entire table.
So comment. Your only options are either comment it out.
Yeah.
Yeah.
Right.
Or you could overwrite the struct underneath it, I guess.
Yeah, but these are usual unit tests, so they usually actually are really fast, right? But sometimes I just want to run it for one particular thing because the output is so verbose or something, because I'm printing out some other additional things, and it's so hard to read the logs or something, and that's the only case I have. Yeah.
I know that I've seen a couple different things, and I've even talked about it myself in the past, of one approach I've seen people take to avoiding that is to, instead of using a slice, is to use a map. And that way they can actually name each test case. And one of the things, I don't like it all the time, but one of the things I do like about it is that it makes you think about what's the purpose of this particular test case versus let me just throw 1,000 random ones in there.
Yeah, that's what I do in order to actually make the logs better. So you can actually log the name of the test, which is usually self-descriptive, and it kind of helps you when you're, reading the logs.
You can do that when in your table-driven test. You're one of the properties of your struct. I usually call that scenario. The first thing is I call it scenario, meaning that this is the scenario that I'm trying to test. And when I call my t.run, right, when I'm doing subtests, the first parameter is the name of the scenario. So the output ends up telling me exactly this is the test you were on, and this is what failed.
Sure.
It's pretty straightforward. Yeah.
Okay, so you do it. Basically, it's the same idea, except instead of a map where the key is the name of the test, you just have the first field of the struct being it.
Exactly.
Okay.
Yeah.
I think I've generally just not preferred that, because then when you're iterating, you're writing your for loop with a range, it's clear which is the test case and which is the test case data and which is the name of the test, if that makes sense.
Yeah,
but it's a very minor nitpick.
Right.
Yeah, Chris James just said that as well on Slack. He said if you use t.run, of course, that subtest, you can then be specific using the run flag. He made the same point.
By the way, table-driven tests were really hard before the subtests, right? Before t.run, it was really hard.
They were. Yeah. Yes.
Yeah.
Now there's no excuse.
I can't think of it, but you guys were talking about how you always start with tables, and I remember there were a couple things that I wrote at one point that coming up with the test without basically it was hard to come up with the table-driven version at first, but I just can't think of the exact cases. I think it was something to do with errors where sometimes I wanted to ignore errors, and other times I wanted to do something else, but I don't remember what it was.
Oh, yeah, I totally can see that. And I think if my assertion is not going to be the same for every input, I try to separate the tests.
I think what it was I had tests where I was actually testing against a real API, and I wanted to verify certain error the errors had more to them that I wanted to assert. So I had to do a little bit more with it.
Yeah.
What I ended up doing was having check functions, but when I first wrote the test with tables, I didn't really want to think about check functions. I just wanted to think about, let me write a test and then I'll come back.
Yeah.
Does anybody else remember? Oh, sorry, Johnny, I'm going to change the subject. So if this is on subject, go for it.
Yeah. Please go ahead.
Oh, I was just going to say, does anyone remember before error was an interface in Go? It used to be a pointer. It was a type, os.error. It just occurred to me then, because I remember fighting with errors at one point, and it was OS error. And of course it changed. I think obviously before V1. Oh, good. I haven't gone crazy. Another thing I like to do.
No,
sorry, just one more thing. Something I quite like to do is if I have a setup function that's going to do some work, I like to return a teardown function from that setup call. So usually I'll call setup, pass in the T, and to all the helpers I pass in the T so that if something goes wrong, they can fail it. I don't need to return any errors. But yeah, then the setup might return something, but it might also return, like context.withCancel, you get a cleanup function which you can just immediately defer to do the teardown.
Yeah, that's what I like. I like the defer, the cleanup.
I will say the only thing I dislike about that is when people just put the double parentheses, and Like if they do it, it's fine. It's just I feel like it's really easy to miss those.
True, like evaluation versus I don't want to.
Like if you defer setup and then another set of parentheses afterwards, people are like, what are they setting up after this?
Yeah, I don't like that.
Yeah, that's where we've just got obsessed with fewer lines of code and we've over condensed it. No, seriously, that absolutely agree. That it hurts readability so much. It just looks weird and magic, which usually I like.
Do you reach for that, like, or do you use that in conjunction to the setup and teardown facilities you get with test main, or like, do you pick one over the other, or like, how do you do that?
Just for a particular set of tests, whether if it's a table test and I want to do common setup and teardown, I'll use it for something like that. Yeah.
Okay, I see. So when you have specific sets of tests, you're trying to do that with, but not for everything.
Yeah, it won't always be appropriate. But for example, if I'm testing a web server, and basically I always am, then I'll create that server in a test helper and return it. And then the teardown function is just the close of that server so that it cleans up nicely after each run.
See, nice.
I wish that there was a way to like globally for a package to set up a setup function and a tear down function. Sometimes feel really variables, and I sometimes like, forget to call the setup or forget to call the tear down, and the test is misbehaving, or it's always been misbehaving, and nobody realized that it was not like cleaning up some of the resources, whatever. I wish that it was easier in the testing package to like just set up something that is global, just always run this, right, in the beginning, and always run this in order to clean up.
I kind of have mixed feelings because I feel like that would get abused with global state too much.
Yeah, true.
Global state's the devil.
Yeah, anything that might be abused is going to be abused, so I agree.
Yes. Anything that can be abused will be abused. Well, I think we've come to the end of our conversation for today. Thank you so much to my panel, Johnny Borsico, Jana Bidugan, and John Calhoun. John, that's how you say your name, isn't it? John.
That's close enough. Yeah.
Thanks to the lag on the internet, I was able to get you there, John. So yeah, we talked a lot. I think one of the key takeaways for me is that doing it right, it's all about the context in which you're doing it. It's about what is it you want to get from writing test code? What do you want to get out of it? If you're writing something simple and small and throwaway, maybe you can skip tests altogether. If you're writing some big, complicated system, the testing needs are going to be very different to smaller apps or little projects of your own, or websites, or even medium-sized projects. So there are no silver bullets, probably, when it comes to testing, just some good philosophies, probably. And I think if you care about your test code and look after it, don't just keep adding to it ad nauseum. Look after it, keep it well-groomed, take good care of it, and I think you'll be all right. You'll be just all right. And yeah, that's it.
I think that's a wrap for today. Thanks for being here and listening, and hope to see you next week.
All right, Go Time is back. It's been so much work behind the scenes, but it's definitely paying off now. And it's so much fun producing this show. We have so many people listening live. Thank you so much for that. We love you. And if you're not yet, hang with us in Gopher Slack. We have a channel called Go Time FM. Look it up. You'll find us. Chat with the community, share stories, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions on every single episode at changelog.com. So head to changelog.com/GoTime, find this episode, and discuss it with the community. And of course, thank you to our sponsors, DigitalOcean, StrongDM, and Rollbar. Huge thanks to Fastly for being our bandwidth partner. Head to fastly.com to learn more. And we move fast and fix things around here at Changelog because of Rollbar. Check them out at rollbar.com/changelog. And we're hosted on Linode cloud servers at linode.com/changelog. Our music is by the one and only Breakmaster Cylinder. And if you want to hear more episodes like this, subscribe to our master feed at changelog.com/master, or go to your podcast app and search for Changelog Master. You'll find it. Subscribe, get all of our shows in one single feed, as well as some extras that only hit the master feed. Thanks for listening. We'll see you soon. because you've listened all the way to the end of the show. Got a little preview here for you of our upcoming podcast called Brain Science. This podcast is for the curious. It explores the inner workings of the human brain to understand behavior change, habit formation, mental health, and the human condition. This show is hosted by myself, Adam Stacoviak, and my good friend Muriel Reese, a doctor in clinical psychology. It's brain science applied, not just how does the brain work, but how do we apply what we know about the brain to better our lives. Here we go.
That applied brain science really stood out to me because I don't want it to just be data. I want you to go, how can this fit? What can I take away? Now, how am I going to change? And that sort of is where you come in more, and even some of the questions I want to ask you, what are some of the most challenging things working in the tech world when it comes to relationships?
Probably the most important one is isolation. More and more the world and companies are being, for good reasons, they're being okay with what they call distributed teams.
Yeah.
And that means that you and I, we work for the same company, but you work from your home office, I work from my home office. I might go into the office a couple times a week if I live local, but even if I live in San Francisco, I'm still probably a remote worker, even though I can hop in an Uber or hop on, the train or whatever and go into the office and be there in a half hour. But why waste the time?
And this is where I would revisit what I want to talk about with resonance. And that whenever we're learning, no matter what thing, it's really helpful when we get feedback that's both immediate and specific. And so when you're by yourself and you don't have any interaction with other people, how can you get any feedback? I mean, you're losing most of the nonverbal communication, and you also don't have all of the voice inflections or facial expression. Have you ever tried to, be sad, feel sad, and smile at the same time? Try it.
It's pretty hard.
Right, because facial expression is exactly what's involved when it comes to empathy, which is relationships. I was reading a research article recently, and it talked about, how couples who are together a really long time end up sort of looking like each other. You ever heard that? Yeah. And so what they've looked at is when we actually empathize with other people, facial expression is really key within that. And so when you empathize with the partner you're with over and over and over again, your face begins to make the same creases and facial expression as it relates to where somebody else is emotionally.
Wow.
Right?
Say it is. So that's creepy.
Well, this is sort of the hotbed when it comes to neuroscience these days, is mirror neurons. And these mirror neurons are what are involved with empathy. And so mirroring, meaning I get another person's emotional world. And so one of the research studies looked at Botox. And what they found is that Botox, because it actually assists in paralyzing facial muscles.
Right.
But then you can't contort your face, so you don't get wrinkles, but actually levels of empathy go down. Right.
Because your physical appearance can't reflect your inner appearance.
You got it. And so when you're working in these remote locations, it might facilitate better work or more focus, and it allows people to be distributed and to capitalize on the talents across the country, right?
Yeah. Wow. So that's like a treasure trove, in my opinion. Talking about in a scientific way, not just like, hey, this is my opinion.
Yeah.
About all the cons of that, because I think what we can do is still have remote work, but do it in more healthy ways. Because I've been self-employed remote worker since 2006. Now I'm a unique animal. I know that. My wife knows that.
Right.
And I'm fine with it. I'm a good human being, but I've got some flaws, and I'm willing to accept and share those to some degree. And I think the problem is we just lack maybe a more purposeful or intentional feedback loop.
Yeah.
Which I think is super important to being able to operate in this world in just good ways. I don't know, healthy ways is probably the best way to use in this show context, is healthy ways.
One of the things that's fundamental, I would say, to being human is change, right? And so sometimes people come in and are really key in our life for a period of time, and then things change. Either we grow or they change in a different direction, and then the relationship changes or that feedback loop gets modified in some way. That isn't always a bad thing. It's just going, my sense of choice actually is a critical component when it comes to feeling good about my life. If I feel like everything is sort of outside of me and I don't have any charge over it, like I didn't choose to work in a more remote location, or I didn't choose to go to school, or I didn't choose this person, then it feels far more oppressive, as opposed to I actually participated in the outcome that I'm actually experiencing. So I then also have more charge over whether or not I want to change it.
I think this feedback loop process that we're talking about here is super common to developers. You know, from people who write code to people who plan and to engineer and to manage and lead. Like, there's no one in the software process that doesn't understand the feedback loop. And the reason why is because in product development, they have this concept of agile. And basically, it means you produce something, you put it out there, and you expect the feedback loop to happen in order to gain insights and course correction to then release another version of it that continually and iteratively becomes more and more improved. So this whole process in day-to-day work in software is normal.
Mm-hmm.
And I think it's interesting how it can apply to their lives and people's lives, you know, to take the same importance of a feedback loop, for example, and apply it.
Right. Well, so this is very much how it goes in relationship, which is why there is an importance when it comes to sort of things resonating. You ever walk into a room or an interaction with a couple other people and like something just feels wonky or off? You're like, I can't put my finger on it. But
Definitely been there.
Right? Well, and so to be able to identify that in relationships and even go, wow, I'm experiencing this person in my world with the limited interactions that I have with them. It hasn't really resonated with me, and so I don't get good feedback. So now I'm going to be more defensive because I feel as though there's a threat. It doesn't necessarily mean the person is threatening. However, my brain is going to tell me, hey, we need to be more protective.
Yeah.
We need to do some strategies so that you're not fully exposed.
You know, one way I look at scenarios like this, I would say as of late, is because have you ever watched a TV show or a movie where the narration, the storytelling part of it, they expose a character in a certain light, and you may dislike that. They may be a villain or villainess, right?
Sure.
But the moment they turn the story to their backstory and why they are the way they are, or why they're acting the way they're acting,
Yes.
you then kind of fall in love with them and you're almost rooting for them.
Right?
I feel like that's the same thing that happens day to day to our lives, is that, you know, there are people who seem villainous or not for us, but we don't understand their backstory and why they are the way they are for us to have and employ that empathy that's required to have this dance, as you say, this iteration of relationship. You know, we just assume they are who they are, and we project, you know, our worst fears onto them, and they become true.
Yes, you got it. This is why in the absence of, you know, a face, I don't really get to engage with people in the same sort of humanness that we are all in. And so you're exactly right. I mean, over and over and over again, because you can identify and go, oh, that's why they're harsh. Or, you know, I recently had an interaction I had shared with someone that I was a competitive gymnastics coach for a number of years. And so somebody thought that my response to them when they were really struggling was kind of harsh, but they remembered that I had told them I was a coach for so long. And they're like, oh, this is just another side of her coming out.
Right.
And I'm not sure I prefer it, but I get it. And then it switched for their reaction, because then they're like, oh, wait, we're on the same team. She's not trying to like oppress me or fight back against me. She actually is helping me, trying to get me to where I want to go.
My wife and I, we've learned this concept of goodwill, right?
Yeah.
I can take your feedback or your criticisms in a different light if I know that you have goodwill for me.
Yep.
Meaning that you're not trying to harm me, that you are for me, not against me. And sometimes change, as we all know, is painful and can be painful. So sometimes the necessary feedback and or criticism that can influence that change can also be painful. But I can accept it differently if I know
Right.
that she or they or whomever is in the scenario with me has goodwill for me, you know. Whereas if you know that they're not for you, then you obviously take it a whole different way, and that's an okay thing. But we often are, you know, in relationship with people that are giving us crucial feedback, and we need to have that kind of that lens. Like, it was significant in our marriage to understand, hey, I know there are times when you give me feedback, I am not happy about it, but I know you have goodwill for me. So therefore I calm down, I listen, I take that in and I process it, whatever, but I take it in a different way because I know that she's for me and not against me.
Yep. One of the key things when it comes to change is a sense of openness, and even relationally, like of going, I need to be able to see how somebody else responds or how they're feeling as based on their perspective of what they're going through and not just my perspective of their perspective. And so this goodwill is like, I believe that we're on the same side and that you're not trying to make it harder for me. But so I can understand if I were sitting where you were sitting, had the background that you had, why you would have taken it in that way. And then I can provide an opportunity to clarify or create more connection, even when it doesn't feel good. And I honestly think this is so much of what's missing in people's relationships. If I look at relational interactions through the notion of conditioning, wherein I get a sort of hit of dopamine, feel good feelings because I went to a person, I had a conversation that didn't necessarily feel good, but there was openness on both parties to hear one another's perspective, that it actually then reinforces like, oh, when I go and I have this exchange with people, I feel better. So now I'm going to go and engage with other people and get the feedback, even if I might not like the feedback, because now I'm buffered and I'm not alone in this and somebody else sees my world.
That's a preview of Brain Science. If you love where we're going with this, send us an email to get on the list to be notified the very moment this show gets released. Email us at editors@changelog.com. In the subject line, put in all caps, Brain Science with a couple bangs if you're really excited. You can also subscribe to our master feed to get all of our shows in one single feed. Head to changelog.com/master or search in your podcast app for Changelog Master. You'll find it. Subscribe, get all of our shows, and even those that only hit the master feed. Again, changelog.com/master.